All right, now the first two proofs are very similar because the theorems are very similar, right? The first two are the ones that we learned on Friday. So the first one there is saying a line drawn from the center of a circle perpendicular to a chord bisects the chord. Okay, we've been working with this theorem now. Now guys, when they are asking you to prove a theorem, it's almost like the theorem doesn't exist. You can't use the theorem to prove the theorem, if that makes sense, right? It's like those questions that we did in probability, the show that or prove that questions. You can't use what they're asking you to prove when you're proving it. Okay, so we have to find a different way of proving that if you have a line from the center of a circle perpendicular to a chord, that those two parts are equal, that AM is going to be equal to BM. You can't say the proof is, because of line from center perpendicular to chord. Okay, we have to do something else, some other mathematical method. Now what they're saying they're given, that is what you will be given in a test or exam, guys. That is the picture that they will give you. They will give you a circle with the center O, and then they're going to give you chord AB, and then they're going to tell you that that line is perpendicular to the chord. Okay, that's the information that's given. RTP stands for required to prove. So what are we proving, guys? What does the theorem say? It says that the line bisects the chord. So that is what we have to prove. So basically we have to prove that AM is equal to BM. That is the required to prove. AM equal to BM. So our final line in our proof has to be, therefore AM is equal to BM with whatever reason. Okay, that is our final thing that we have to say. The construction is the stuff that is in dotted lines here, like I said. So we are going to construct radii OA and OB. So like I said, it's already been drawn in for you, but in a test or exam, you are going to have to draw those in yourself. You're going to have to remember that that's the construction, guys. They're not going to tell you that in the question. You must memorize what the construction is. And you also get a mark for doing that. For showing it in writing and for doing it on the picture. Yes?
Okay, so it's construction that will be drawn.
Yes. Alright, now guys, what we're going to do here is we are going to remember when we did Euclidean Geometry and we worked with congruency, congruent triangles, right? We are going to prove that these two triangles are congruent, because if they are, then that means that all their sides and all their angles are equal, right? So guys, OA and OB, those are radii of the circle, so they're equal to each other, right? Yes? We have a 90-degree angle there. What is that angle going to be? OMB is also going to be 90. How do I know that? They told us that OM is perpendicular to AB, meaning that both of those angles are 90 degrees, right? So we have a hypotenuse, we have a right angle, and then guys, look at OM. OM is a common side between the two triangles. So we're going to use RHS, right angle, hypotenuse, side, to prove that these two triangles are congruent. Guys, I can't say that AM is equal to MB in my proof, right? I can't use that to prove that they're congruent, because that is what I'm trying to get to. That's what I'm trying to prove. Okay, so you can't use, I'm going to make a note on the side, don't use AM equal BM in proof. If you do that anywhere, it's an automatic 0, right? If you are using what you're trying to prove in your proof, you can't do that. Okay, that's what we need to end up with. Remember, that has to be the last line of our writing out. So now we're going to say, in triangle AOM and triangle BOM. One, we're going to say angle OMA is equal to angle OMB, which is 90 degrees, right? So we're going to say OMA is equal to OMB. And guys, since we want to use right angle hypotenuse side, we do actually have to state that it's a right angle. So you have to say that it is 90 degrees. The reason for that is OM perpendicular to AB. or you can just say given also. That would also work because that was given. So it's fine if you just write given. Alright, so there we have our right angle. Now we're going to talk about our hypotenuses. So we're going to say OA is equal to OB. Reason is going to be radii. Right? Because OA and OB, the lines that I drew in, those are radii, and we know that radii of a circle are always equal. So OA is equal to OB. The reason is radii. And third line is going to be our side. OM is common. Therefore, triangle AOM is congruent to triangle BOM. And the reason is right angle, hypotenuse, side. And since these two triangles are congruent, that means that AM has to be equal to BM, because remember, congruent triangles are identical. All their sides and all their angles are equal. So now we're going to say, therefore, final line of our proof, what was required to prove, AM is equal to BM, and the reason for that is congruent triangles. Mm-hmm. Let's take a look off. Right, does that make sense, guys? So we've actually proven that this theorem is true using other maths, right? Not using the theorem. So we've shown now that if you have a line from the center of a circle that's perpendicular to a chord, you could always construct your triangles and prove that those lines are equal via congruency. Now guys, I don't want you to think, because this is a very common misconception, please don't think that now, whenever you want to use this theorem, right, line from center perpendicular to chord, that you have to go through all of these steps. No. Okay, you don't have to. We've just done a worksheet. You can just use the theorem. Like if you're thinking of Pythagoras, guys, Pythagoras also has a theorem that you're actually going to, or a proof rather, that you're also going to learn in grade 12. But we just use Pythagoras, right, because we know that it's true. You don't have to show the proof every time you use the theorem. Okay, the only time that you are going to write this down is if they ask, prove the theorem, which states, and then they're going to write that down. Okay, so maybe we should add that because that's very important. So if they say, maybe if you have some space there, if they say, prove the theorem, and then they're going to tell you which theorem to prove. They'll write it out. Right, only then are you going to write this down. If it's just a question and you need to use the theorem, you just use it like we've done in the worksheet already. Alright, are we okay with that? Okay, we're going to do the second one now. The second one is very similar. We're also going to use congruency. The information that we have is just slightly different. Okay, but we're going to use the same method. So for the second one, that is the converse of the first one. That one is saying a line drawn from the center of a circle to the midpoint of a chord. So now, guys, it's very faint, but can you see there that it's given that these two are equal to each other? Right? That's now the given information. What is required to prove is the last bit, that it's perpendicular. Okay, so that is what we're going to have to prove. We are going to have to prove that OM is perpendicular to AB. Alright, so next to required to prove, you can just write OM perpendicular AB. Again, please highlight these dotted lines. Again, this is not going to be given. That is, again, the construction. So for these two proofs, you need to use the same construction. Okay, so for our construction, we're going to say radii OA and OB. Now we are again going to use congruency to show that these two triangles are identical. But now, guys, we're going to use side, side, side. We can't use right angle, hypotenuse, side now because we don't have a right angle there. We need to prove that we have a right angle. Okay, so we have that these two lines are equal. That was given, right? We have that OM is a common side. And then we also have that OA is equal to OB because they are radii. So we're going to use side, side, side for this proof. Okay, so again, we're going to write, just like in the previous one, in triangle AOM and triangle BOM. And now we're just going to list those sides. Doesn't matter what order you list them in. So I'm going to write here OM is common. Next one, I'm going to say OA is equal to OB. And the reason for that is radii. And then our last pair of sides that were given as being equal is AM is equal to BM. And the reason for that is going to be given. If you read through the given stuff, I didn't actually do that now, but you can see there it was written with AM equal to BM. Okay, so that information was given. Therefore, triangle AOM is congruent to triangle BOM. And the reason now is going to be side, 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 SSS. Right, now guys, what that means is that these two angles are going to be equal to each other, right? Remember, when two triangles are congruent, all their angles are the same, all their angles are equal. But these two triangles lie on a straight line. Yes, are we looking at OMA and OMB? Those two angles lie on a straight line, so what must they add up to? 180, right? Two angles on a straight line, or however many angles, two in this case, on a straight line, add up to 180. And since they are equal to each other, what is 180 divided by 2? 90 degrees. Okay, so that is where we're going to get the perpendicular. So now we're going to say, therefore, so this one has just an extra step that the previous one doesn't have. We're going to say OMA is equal to OMB, sorry. And the reason for this is now congruent triangles. And OMA plus OMB is equal to 180. And the reason for that is angles on a straight line. Therefore, OMA, and I'm just going to say again, equal to OMB equal to 90 degrees, because it's 180 divided by 2. And now we just, as another extra step, we just have to end our proof by saying, therefore, OM is perpendicular to AB. Alright, so we have some extra steps in this one. We can't, unfortunately, just end where we say that the two angles are equal, because we have to prove that, yes, they're equal, but also they're equal to 90. Okay, because that is what we're required to prove, that OM is perpendicular to AB. So please add in the line where you say that the two angles together is 180 because of that reason, therefore they're 90. It probably would have been fine if you skipped this line, actually, because that is implied when you're saying that OM is perpendicular to AB, that those angles are 90, but yeah, I always write that line in. Okay, guys, a proof like this, even in matric, is always worth 5 or 6 marks. Okay, so in your test coming up, which is out of 50, if they ask you this proof, for example, and it's 5 marks, that's 10% of your mark. Alright, and a lot of the time, people say, oh, I'm not going to study it, it's a waste of time. You will get a proof. Alright, and if you don't study your proofs, you're going to lose 10% at least of your test. It can even be 6 marks. Alright, depending on what they award marks for. So please, it's a good idea to memorize these, and if you struggle with that, write it out a bunch of times.